In this video, we're going to do examples relating to the compound angle formulas that we recently learned. So without using a calculator, suppose we wanted to evaluate the sine of 13 degrees cos of 47 degrees plus cos of 13 degrees sine of 47 degrees. Well, this looks pretty tough to do without a calculator, but we might remember that if we simply let A equal 13 degrees and B equal 47 degrees, then what we've got is sine A cos B plus cos A sine B. And that is nothing different than the formula for the sine of A plus B, which in this case would be the sine of 13 degrees plus 47 degrees. So we can actually use that knowledge. We have the sine of 13 degrees plus 47 degrees, which is the sine of 60 degrees, which is just the square root of 3 over 2. All right, next example. What if we wanted to know these three values and we didn't want to be using a calculator? Well, all we really need to be able to do is construct 165 out of two values, values for which we know the sine, cos, and tan. So, for example, we know the sine, cos, and tan of 120 degrees from our unit circle work, and we know the sine, cos, and tan of 45 degrees. Well, 120 degrees plus 45 degrees is 165 degrees. So those will work. So if we can express 165 degrees this way, we're in business. So let's use that. That 165 degrees equals 120 degrees plus 45 degrees. Now I mentioned this here also just to show you, you don't have to pick this one way of doing it. If you instead chose to say that 165 degrees is 225 degrees minus 60 degrees, that would be okay as well. There'd be nothing wrong with that. But for this question, we're going to focus on letting 165 degrees be known as 120 degrees plus 45 degrees. Now, the sine of 165 degrees is definitely the sine of 120 plus 45 degrees. Well, the sine of A plus B is sine A cos B plus cos A sine B. So we can just plug those numbers into the formula like that, letting A be 120 degrees, letting B be 45 degrees. If we do that, we have root 3 over 2, root 2 over 2, plus negative 1 over 2, root 2 over 2. Multiplying our numerators, root 3 and root 2 gives us root 6. Multiplying our denominators, 2 and 2 gives us 4. And we have a plus sign in the middle, but we're multiplying negative 1 and root 2, so what we really are doing is subtracting root 2. And in the denominator, we have 2 times 2, which is 4. So root 6 over 4 minus root 2 over 4 is root 6 minus root 2 quantity over 4. That's the sine of 165 degrees. Well, what's the cos of 165 degrees? Again, this is going to be cos of 120, cos of 45 minus sine of 120, sine of 45. The cos of 120 degrees is negative 1 over 2, and the cos of 45 degrees is root 2 over 2, and then we're going to be subtracting. The sine of 120 degrees is root 3 over 2, the sine of 45 degrees is root 2 over 2. Well, negative 1 times root 2 is negative root 2. Root 3 times root 2 is root 6. So we have negative root 2 over 4 minus root 6 over 4, which ultimately is negative root 2 minus root 6 quantity over 4. And we can call that negative root 6 minus root 2 over 4. Okay, so we've got the sine of 160 degrees and the cos of 165 degrees. Now let's find the tan of 165 degrees. To do this, we're going to do a method 1 and a method 2. Okay, method 1. The tan of 165 degrees is the sine of 165 degrees over the cos of 165 degrees. So we just place each of those values there. And then we have a fraction divided by a fraction, so we invert and multiply. When we do that, we can cross out these 4's. And what we have is root 6 minus root 2 all over negative root 6 minus root 2. That's what the tan of 165 degrees is. But we should rationalize our denominator. When you see that denominator like that, that's an irrational denominator. And we know how to rationalize denominators when there's only one term. For instance, if we have a number like 3 over root 7, we know that we can just multiply by numerator and denominator by the irrational component of the denominator, and we get this, and we've rationalized our denominator. Well, sometimes, though, we can't use that method because we have two terms in the denominator. When that happens, we rationalize by multiplying numerator and denominator by the conjugate of the denominator. Okay, what is the conjugate of the denominator? Well, before I go to the next slide, I'll just show you that when you have two terms, let's say a minus b, the conjugate is a plus b. If we have the two terms a plus b, the conjugate would be a minus b. If we had the two terms negative a minus b, the conjugate would be negative a plus b. And so you see, all we're really doing to get the conjugate when we have two terms is just changing the sign of the term in front, the sign in front of the second term. So when we have here root 6 minus root 2 over negative root 6 minus root 2, what we're going to do is multiply top and bottom by the conjugate of negative root 6 minus root 2. The conjugate of negative root 6 minus root 2 is negative root 6 plus root 2. And we have to multiply the numerator by the same thing because, of course, we need to multiply top and bottom by the same quantity. So when we do that, we have this right here. That's the step we just showed. And now we're just going to distribute root 6 times negative root 6, root 6 times root 2, negative root 6 times, negative root 2 times negative root 6, and negative root 2 times root 2. Similarly, we're going to distribute in the denominator as well. Okay, distributing all those terms. Now, when we recall here that when we multiply one square root times another, we can keep the square root symbol and simply multiply quantities beneath the radical. So when we multiply root 6 times negative root 6, for instance, we'll get negative root 36, and on and on. And we'll continue, we'll do that, distribute the way we showed earlier. When we do that, we end up with negative root 36 plus root 12 plus root 12 minus root 4 over root 36 minus root 12 plus root 12 minus root 4. Now I want to show you something. Whenever you use this method, in the denominator, you're going to get something like this. You're going to get an irrational term, and it's going to be able to eliminate itself through collecting like terms. Negative root 12 plus root 12 ends up eliminating itself. So what we end up with here is negative 6. When we have this plus root 12, that's plus 2 root 12. And then on the end here, this negative root 4, that's minus 2. As mentioned earlier, that negative root 12 and positive root 12 cancel each other out. The square root of 36 is 6, and the square root of 4 is 2. So we actually end up with this expression right here. Now that expression, when we take this negative 6 and negative 2, they combine to be negative 8. We have plus 2 root 12, and then in the denominator we have 6 minus 2, which is 4. But notice that the square root of 12 can actually simplify. The square root of 12 is none other than 2 root 3. So we have 2 times 2 root 3 in the numerator, which is 4 root 3. So actually our numerator is negative 8 plus 4 root 3 all over 4. Okay? Which is what we have right here. Then we want to simplify that, so we see that we can factor 4 from the numerator and cross it out with the factor of 4 in the denominator, and we're left with negative 2 plus root 3. So the tan of 165 degrees is negative 2 plus root 3. Well, earlier I said that's method 1. You might be wondering, what's method 2? Well, method 2 is a little bit more direct. We just say, use our formula, our compound angle formula. The tan of 165 degrees is the tan of 120 degrees plus 45 degrees. The tan of a plus b is tan a plus tan b over 1 minus tan a tan b. So we have the tan of 120 plus the tan of 45 over 1 minus tan of 120 tan of 45. That's just the same as saying sine of, we want to know what the tan of 120 is. Well, the tan of 120 can be evaluated this way. Okay, we know the sine of 120 and cos of 120, so we use those to our advantage to recognize that the tan of 120 is negative root 3. And we know what the tan of 45 degrees is because we know what the sine of 45 degrees and cos of 45 degrees is. That tells us that the tan of 45 degrees is 1. So using these values for tan of 120 and tan of 45, we plug those in, and we end up with negative root 3 plus 1 over 1 plus root 3. But as mentioned earlier, what we have here is an irrational denominator. Now, how do you rationalize the denominator when there are two terms? As said, we multiply top and bottom by the conjugate of the bottom. So again, the conjugate of a minus b is a plus b. The conjugate of a plus b is a minus b. The conjugate of negative a plus b is negative a minus b. All we're doing is changing the sign of what's in front of the second term. So the conjugate of that denominator will be 1 minus root 3. But since it's a fraction and we're multiplying the denominator by that, we have to multiply the numerator as well. So that'll be our strategy on the next slide, multiplying numerator and denominator by 1 minus root 3. When we do that, we then distribute like we did in the last question where we used this method. And we do the same thing with our denominators, of course. And there's a lot of distributing here. And what happens is we get these two terms here. But notice what I said would happen in the denominator. You'll get a couple of irrational terms that are the same. One negative, one positive. They'll cancel each other out. And so this square root of 9 right here is the same as 3. And we've got this 1 right here, which we keep. And then in the numerator, the other two terms are negative root 3 and negative root 3, so they simplify to negative 2 root 3. In the denominator, we have this middle part that cancels out, so we're just left with 1 minus root 9, which is 1 minus 3. So when we simplify that, we get 4 minus 2 root 3 over negative 2. We can factor negative 2 out of the numerator, and we already have a factor of that in the denominator. So these negative 2's cancel out, and we're left with the tan of 165 equaling negative 2 plus root 3. That's what we got using method 1. So really, it's up to you which method you use. And now we've got answers for the sine, cos, and tan of 165 degrees, all with rational denominators. Okay, what if we wanted to know an expression equivalent to the sine of x plus 3 pi over 2? Well, it sure would be helpful if we had an equation for the sine of a plus b. Oh wait, we do. Isn't that convenient? We're going to use that to our advantage. We know that the sine of a plus b is sine a cos b plus cos a sine b. So if a is b and if a is x and b is 3 pi over 2, then we've got the sine of a plus b, which is the sine of a cos of b plus cos of a sine of b. Now, the cos of 3 pi over 2 is 0. And the sine of 3 pi over 2 is negative 1. So what we've really got is sine x times 0 plus cos x times negative 1, which is 0 minus cos x, which is negative cos x. So the sine of x plus 3 pi over 2 is the same as negative cos x using our compound angle formulas. And finally, let's try this question. Suppose that we know pi over 2 is less than or equal to alpha is less than or equal to pi, and pi is less than or equal to theta is less than or equal to 3 pi over 2. In other words, we know that alpha is up here in quadrant 2, and we know that theta is down here in quadrant 3. Also, we know the sine of alpha and the cos of theta. Well, we want to know what's the sine of alpha minus theta. Okay, well, let's start with alpha. We know that alpha is in quadrant 2. Now, if alpha is in quadrant 2, that means we know y is positive and x is negative. That's true in quadrant 2. Okay, so Since sine of alpha is always y over r, that's a formula that we know from earlier in this year and last year as well. Since the sine of alpha is y over r, and we know y is positive and we know r is always positive, that means we can say for our question, let y be 4 and let r be 5. That would give us our 4 over 5, which is what it says in the question. Okay, so y is 4, r is 5. We know this formula right here, x squared plus y squared equals r squared. So we plug in our y value of 4 and our r value of 5. X squared plus 16 equals 25, which means x squared equals 9, which means x is equal to plus or minus the square root of 9, which means x is equal to plus or minus 3. But go back a second. Earlier in the question, I said x is negative when you're in the second quadrant and y is positive. Well, if x is equal to plus or minus 3, but I know x has to be negative, that means x equals negative 3. It can't be positive 3, it's got to be negative 3 because of the quadrant we're in. So since cos of alpha is x over r, and earlier we said r is 5, right up here, that means x is negative 3, r is 5, cos alpha must be negative 3 over 5. So we've got knowledge of the sine of alpha right here, 4 over 5, the cos of alpha right here, negative 3 over 5, and the cos of theta right here, negative 5 over 13. Let's see if we can find the sine of theta and complete the set. Well, we know that the cosine of theta is negative in quadrant 3. So theta's down here. Well, cos is negative down there. We know that in part because when we're in quadrant 3, x must be negative, y must also be negative. R, for the record, is always positive no matter what. So what we're going to do, since we know cos theta is x over r, and we know cos theta is negative 5 over 13, we're going to say x is negative 5 and r is 13. We're actually going to plug these numbers in right there because they're used in our formula. So we know the value of x, we know the value of r. We're going to say that x squared plus y squared equals r squared. We know that to be true. Plug in an x value of negative 4, a r value of 13, and let's solve for y. When we do that, we get y squared equaling 144, which means y ends up being plus or minus 12. But now keep in mind where we are. We're in quadrant 3. That's where alpha is. We know that when you're in quadrant 3, y is below, the y coordinate's got to be negative. So that means y is negative. So y must be negative 12. And since sine theta is always y over r, and since y is negative 12 and r is 13, that means sine theta must be negative 12 over 13. So from the previous slide, we learned the values of sine alpha, cos theta, and cos alpha. Now we know the value of sine theta, and all we have to do is put them together. Because the question is asking us for the sine of alpha minus theta. Well, the sine of alpha minus theta is sine alpha cos theta minus cos alpha sine theta. Plugging in our values for sine alpha, cos theta, cos alpha, and sine theta, we get, and multiplying, we get negative 20 over 65 minus 36 over 65, which is equal to negative 56 over 65.